Reinforcement learning algorithm helps train thousands of Reinforcement learning algorithm helps train thousands of robots simultaneously.
To help speed up reinforcement learning, a team from NVIDIA developed a GPU-accelerated reinforcement learning simulator that can teach a virtual robot human-like tasks in record time. With just one NVIDIA Tesla V100 GPU and a CPU core, the virtual robot learns to run in less than 20 minutes. The simulator can even support hundreds to thousands of virtual robots at the same time on a single GPU. This allows them to interact and collide with each other. The NVIDIA team benchmarked the system on 4 tasks: an ant running with 2 legs, humanoid running, humanoid flag run harder, humanoid flag run harder on complex terrains. The virtual agents trained on complex terrains are able to adapt to environments unseen during training, including climbing up and down stairs and recovering from falls from heights.
Something that's much, much harder to do, let me show you the next one. This is why we created Isaac's Lab. Isaac's Lab works like this. It's a holodeck, and this lab has several characteristics. First, it's photorealistic. And the reason that it has to be photorealistic is because everything that Isaac or the robot sees has to look like in the future when it's not in this virtual environment. So it has to look photoreal, it has to look like the real thing. The second thing is it has to obey the laws of physics. If it doesn't obey the laws of physics, then the things that it learns in this holodeck will not be true when it comes into the real world. It has to obey the laws of physics. Water has to behave like water. Touching something has to behave like touching something. Something heavy would be something heavy. Gravity would be simulated. Okay? And so it has to obey the laws of physics. The third is it has to have artificial intelligence. The artificial intelligence will come into the Isaac Lab in 2 ways. First way is through a virtual Jetson. The robot inside Isaac's Lab will run the software stack that will run on Jetson exactly as it was, exactly as it is. And that software is basically the brain of the robot. And that brain of the robot will have an algorithm that is injected through the OpenAI gym. So reinforcement learning comes in through here. It runs on the virtual Jetson above. The robot definition, its arms, its physical characteristics, the actuators and the effectors, the cameras, all the sensors are all inputted using a standard robotics input format. The entire environment is designed. You can import the entire office, the entire city. You can import whatever you like to import into this world that you would like the robot to grow up in. Okay? Whatever environment you would like the robot to grow up in, you can import it into this environment. And all of this is running on our GPUs, and so it would be incredibly fast. Now, the reason why you need it to be fast is this. You want it to look like the real world, you want it to behave like the real world, but you don't want time. You don't want it to behave and limited by time. You want super real time so that your robot can learn through repetition as fast as possible. Okay? So this is the Isaac Robot Simulator. Let's show it to him. Titus, if we can just change. Titus, are you there? Okay, all right. So this is the robot simulating environment. And what we've done here is we imported a little tiny hockey ring. Something simple. The puck is simulated. the ice is simulated, the net is simulated, okay? And so if I could just notice, first of all, do you see Isaac? Isaac, can we go into full screen mode maybe? So this is Isaac learning. And notice in this virtual world, Isaac doesn't have to be just one robot. The way we do it is this. We replicate Isaac a whole bunch of times, and we let them all learn randomly. It's literally learning randomly. And once it starts randomly learning, it gets positive feedback every time it does something good. It gets negative feedback when it does something not as good, okay? And so all of these robots are learning at the same time. We stop after a while, we take the smartest robot's brain, and we replicate it everywhere. And then we can continue. Does that make sense? Okay? We train for a while, we take the smartest student, we give every student the same brain, and then from there, we continue. Imagine if we can teach children like this. This is incredible, right? So notice some of them are doing a pretty good job, some of them are not doing a very good job. Okay, so this is Isaac learning. Now this is, of course, just hockey. We could let Isaac learn almost anything. We also let Isaac learn how to golf. Titus, can we go to golf? In this particular environment, of course, the grass has to be simulated. The physics of the ball. Now, remember, we didn't show you the beginning of the simulation, but in the beginning, Isaac doesn't even know how to pick up the golf club. It doesn't even know which side of the golf club to use. But because it repeated it so many times, it eventually figured out that the best way to hold the golf club is with the putter on the bottom. Okay? Isn't this amazing? And it just figured out where the hole is through just... All right. Is it going to go in? Is it going to go in? Go. Go. Isaac, you could do it. You could do it. Yeah. Good job. Next year we'll send, thank you, Titus. Next year we'll send Isaac to the Masters. And then lastly, all the reference platforms. Remember what a robot is. A robot has basically three fundamental things. It has to have sensors. It has to reason. It has to have artificial intelligence. It has to understand what it sensed, create a world model, and reason about what to do. Artificial intelligence. And the third is apply motor skills. Applying motor skills is also an artificial intelligence problem. Sensing is an artificial intelligence problem. Reasoning is an artificial intelligence problem. We now finally, for the very first time in computing history, have within our hands the three fundamental capabilities necessary for robotics to happen. And of course, we also know that sensors are proliferating like crazy, and we now have all of the necessary capabilities to do so. Each one of these different robots have different sensor suites and different actuators. Some of the sensors are camera, some of the sensors are LiDAR, some of the sensors are stereo camera, some of them are infrared. Okay, this doesn't really matter what kind of sensors you have. The reasoning is done on Jetson TX2, and the actuators, some of them are wheels and some of them are propellers. And so this is basically how it works. We created a processor, the most powerful processor the world has ever seen, Volta. We integrated into a system, the highest performance computing system the world has ever built with our partners. It's called HGX. A software stack on top called the NVIDIA GPU Cloud has all of the operating systems and all the frameworks and tools necessary to train networks. It creates a network, and we have a tool, an optimizing compiler called TensorRT. The NVIDIA TensorRT takes a network that has been trained and optimizes it for Jetson or optimizes it for a local computing platform. That trained network is then downloaded onto Jetson, and as a result, you have artificial intelligence at the edge. AI in the cloud, AI at the edge. Okay? So NVIDIA powering the AI revolution.